Hello and welcome to the Unit 5 Section 1 video on rational function key features and transformations. So in the previous units we've talked about key features and transformations for various number of functions including absolute value, quadratic and cubic functions. And in the last unit we've even delved into some of the key features of higher order polynomials. Well, now what we're going to do is we're going to take a look at rational functions, which are just functions that are expressed in a form of a fraction. Okay, so a rational function is one that can be written as a polynomial divided by a polynomial. The most basic example of a rational function is 1 over x, which is often referred to as a simple rational function. And it's also going to be our parent function for a rational function, 1 over x. The graph of a simple rational function has two curves separated by a vertical asymptote and a horizontal asymptote. So this may bring you to the question, well, what is an asymptote? Well, an asymptote is a line that a graph approaches as the value of x becomes extremely large or small. And you'll clearly see that as we start to do some examples of this. So let's talk about the rational parent function and what that looks like. So here we have a table of values. They've already been filled in for you. If we take our x values and just plug them into our parent function, if you put 1 in, you get 1 over 1, which is just 1. If you put 2 in, you get 1 over 2, which is a half. If you put 3 in, you get 1 over 3, which is a third. And then the same thing as you go over to the negative side. Now you'll notice that there is no value for 0 because we can't divide by 0. So since we can't divide by 0, we're going to end up with an asymptote that goes along the y-axis. Okay, so you indicate an asymptote, which is a value that the function cannot be, by using a dashed line. And you may remember using a dashed line when we were doing inequalities. If we were not including what's on the line, we use a dashed line. You're also going to end up with a horizontal asymptote along the y-axis. And you'll see very clearly why that is here when we start graphing this function. So let's start taking a look at some of the specific points here. So if we take a look at the point 1, 1, we're going to have that graphed right here. Okay? At 2, x equals 2, we have a y value of 1/2. So at 2, we go up by a half. And then at 3, we go up by a third. Now, what if we had the x value be 1/2? Well, 1 over 1/2, it just ends up being 2. So you have 1/2, 2, and then you'd have 1/3, 3. Now, you would end up with a line that looks sort of like this. It's a curve, and it approaches the x-axis on one side and approaches the y-axis on the other. Now we got to take care of the negative values. If we go over to -1, we go down to -1. There's our first point. We go back to -2, we go down a half. We go back 3, we go down a third. And the same could be said for -1/2, -2, -1/3, 3. And so you end up in the quadrant diagonal from the other quadrant that we end up with a curve here as well. Okay? And so this is what our graph is going to end up looking like. You've got opposing quadrants diagonal from one another, and you have curves that approach both the x and the y-axis. And that's how we're going to describe this function shape. We're going to describe it as approaching the x and y axis in quadrants 1 and 3. Okay? Now we have a vertical asymptote. Our vertical asymptote being this vertical line that's dashed. What value is that at? It's at 0. It's at x equals 0 because this is where x is 0 along the x-axis. Likewise, our horizontal asymptote is at y equals 0. Now, the domain for this, you might be tempted to say all real numbers from left to right, but you got to remember we do not ever touch 0. That cannot be a solution. So we include everything except 0. So negative infinity to 0, union with 0 to infinity. Our range is the same thing from bottom to top. With that horizontal asymptote prevents us from using 0. Now for the rate of change, let's look at this from 3 to 3, you have a rate of change of 1. From 2 to 2, you have a rate of change of 1. Same thing on the other side. So generally speaking, if you're moving from one thing to another, your rate of change is 1. Positive interval, well, we are above the x-axis from 0 to 1. We're negative from negative infinity to 0. So I should have said we're positive from 0 to infinity. We're negative from negative infinity to 0. So positive from 0 to infinity, negative from negative infinity to 0. Now, where are we increasing? Well, the graph starting from this side is decreasing. And then we pick it up here, and it's still decreasing. So at no point are we actually increasing. So therefore, your increasing interval is none. But we are decreasing everywhere else except for where there is no value for x, which is at 0. And then our end behavior. This is the first case where our end behavior is going to look different. So if you look on the right side, as x approaches infinity, so we're going this way, we're not approaching negative infinity. It's approaching this asymptote. So therefore, what we say is, as x approaches infinity, f of x is approaching 0. And then as x is approaching negative infinity, f of x is also still approaching 0, just from the other side of the axis. And you can see that here on the left. We are getting closer and closer to this horizontal asymptote. So that is some of the key features of a rational function. All right, now let's talk about rational transformations. So a simple rational function with different asymptotes and or increasing for all real numbers is simply a transformation of this parent function. Okay, so the form f of x equals a over x minus h plus k gives us the location. So you noticed in absolute value and quadratic, it gave us the location of the vertex. In cubic, it gave us the location of our inflection point. And in this case, it's going to give us the location of the intersection of the asymptotes. All right, so let's talk about some of the transformations. Horizontal translation is when h is positive. So a horizontal translation to the left is when h is negative. Vertical translation happens when k is positive. And you go down when k is negative. I'm going through these fairly quickly because this is all stuff that is the same for the last 3 functions that we did. Okay, so let's look at examples of all 4 of these. An example of h being positive, you have f of x equals 1 over x minus 4. Now you're saying, why is it minus 4? Because h is positive. If you look in the parent function up here, the h follows a minus sign. So 4 itself is positive. What if 4 was negative? Well, then you'd have 1 over x minus negative 4, which would look like 1 over x plus 4, because minus a negative gives you positive. That should be x. All right, so now let's talk about vertical translations up. So you've got f of x equals 1 over x, and say plus 5. Okay, so that one looks like it makes sense, and so does the other f of x equals 1 over x minus 5 for when k is negative. All right, well, we have a reflection across the x-axis when a is negative. Okay, so that's the same. So a, being that top number, you'd have f of x equals negative 1 over x. Now that negative could sit out in front of the fraction if you wanted. That would not change anything. All right, so for reflection across the y, we're going to put not applicable. And the reason it's not applicable here is, what if we put the negative in front of the x? Well, it does the same thing as what a reflection across the x-axis does. All right, vertical stretch is when a is greater than 1. So an example of that would be f of x equals 2 over x. And then you could have a vertical compression, but we're not going to get into that here because you'd end up with a fraction on top of a fraction, and we're just not going to cover that. So vertical stretch is all you'll have to worry about if you have some number on the top of your fraction there. So let's do a few examples where we identify the transformations that have occurred. All right, so for a here, we have a minus 4 in the bottom, so h is positive, which means that we have a translation to the right by 4. And then we have a plus 3 on the end, which means we go up 3. For b, we have a negative in front, which means we are reflected across the x-axis. And then we have a 3 on the top, which means we have a vertical stretch of 3. And then we have a plus 1 down here, which means we have moved left 1. For C, we have a number in the top. That means we have a vertical stretch of 2. And then we have a minus 8, which means we went down 8. And then finally, for the last one, that negative in the top tells us that we are reflected across the x-axis, but there's no stretch because it's only a value of 1. And then the plus 3 tells us we're moving left 3, and then the plus 4 tells us we go up 4. So a lot of this is very similar to what you've already seen in the previous transformations that we've already covered. All right, let's talk about graphing. Now, in this case, we're not going to really graph too specifically when we get to graphing our curves, okay? You can do that. You can create a table of x values and y values. But the main thing we're going to try to make sure we graph correctly are the asymptotes, and then get which quadrants that this graph is in and make sure we have the general shape correct. So let's do that. First, let's identify our asymptotes. Our horizontal asymptote is going to be at y equals 2, because you use your k value for that. Your h value goes with your vertical asymptote. So we've got vertical asymptote at x equals 3. So we can come over here and plot that. X equals 3 is our vertical asymptote. In fact, I'm going to try to do this just a little bit neater than this. So there's our vertical asymptote at x equals 3. We have a horizontal asymptote at y equals 2. Okay, so there are the asymptotes plotted. Now, we're going to just generally draw what our curve looks like. We know we're not stretched, and we know that it's going to be in quadrants 1 and 3 because it's not reflected. So you're generally going to have a graph that looks like this, where you're approaching the x and the y, at least your asymptotes, and then this one's going to generally look like this. All right, let's move on to B. So for B, we are not going to bother with positive and negative intervals because we're not doing anything specific in terms of graphing here. So we are going to just omit these two. but we can figure out what our asymptotes are and do a little graphing from there. So let's at least do that. So we know that our vertical asymptote is going to be at -2 from our h value. And we know that our horizontal asymptote is going to be at -1 from our k value. And then we know that from it being negative that we are going to be going into quadrants 2 and 4. So you're going to end up with something that looks like this. Okay, and then we go into the other quadrant here, and you're going to have something that looks like that. So again, we're just looking for the general shape of the curve here. We're not going to get too specific in the graphing. All right, for C, let's get our asymptotes. Well, we know that our vertical asymptote is going to be at 5. And then we know, because we've got no k out here, that our horizontal asymptote will be along the x-axis at 0. And it looks like I got that line a little crooked. Let me fix that for you. So there's the vertical asymptote at +5. There's our horizontal asymptote at the x-axis. And now we're going to just sketch. It has a stretch of 2. We'll try to kind of show that a little bit, but we won't be able to show that too specifically. Let's see if I can get this line drawn. Okay, so that's about as good as I'm going to be able to do here. Perhaps this one will be a little bit clearer. And that one's a little bit better. And we know that we're in quadrants 1 and 3 from the asymptote axis because we are not reflected. There's no negative sign in front. So let's talk about what the domain is. From left to right, our domain goes from -infinity until we get to the asymptote, which is at 5, union with 5 to infinity. Our range goes from -infinity to 0, union with 0 to infinity. So basically everything except for the asymptote itself. All right, let's move on to D. So again, let's figure out what our asymptotes are. So we've got no h value, which means that our vertical asymptote is going to be right along the y-axis. And then we have a -5, so our horizontal asymptote is going to be at -5 for our k value. And now we're just going to sketch. We know it's negative, so we're going to have this in quadrants 2 and 4. And we know that there is a stretch of 3, which we kind of tried to show here, but it's not going to be particularly exact here. So let's talk about the increasing value. Well, it's increasing pretty much everywhere except for that horizontal or that vertical asymptote. So you're going to have -infinity to 0, union with 0 to infinity. And then our end behavior, as x approaches infinity, f of x is going to approach -5. As x approaches -infinity, f of x approaches -5 because it's approaching this horizontal asymptote, which is at -5. That's where your y is going. Okay, so we've talked a little bit about sketching a rough graph here. Let's now talk about what happens when you're given the graph. Can we write the equation for it? So let's talk about what we need to know. We need to know what our h, k, and a are. Okay, so let's start with a. Well, this is how we find it. If we start from the middle of your asymptotes, you go over 1 and then up. See how many you have to go up to get to the graph. And in this case, you only have to go up 1. So our a value is 1, and we're in quadrants 1 and 3, so it's positive 1. Our h value is going to be our vertical asymptote, which is at negative 2. Our k value is going to be our horizontal asymptote, which is at negative 3. So from here, all we got left to do is write the equation. Y equals 1 over x plus 2 minus 3. All right, for the second one, our a value, let's go, well, first of all, we're in quadrants 2 and 4, so we know it's going to be negative. So we go over 1 and we go down 1, 2, 3, 4. We had to go down 4 to hit the graph, so our stretch is 4. And then our h value is our vertical asymptote, which is 1. Our k value is our horizontal asymptote, which is 2. And then from here, we can write the equation. Y equals negative 4 over x minus 1 plus 2. All right, on to C here. We have A being positive because of the being in quadrants 1 and 3. And then we go over 1 and we have to go up 2. So A is going to be 2. Our H is going to be 0 because our vertical asymptote's at the y-axis. And our K is going to be negative 5 because that's where our horizontal asymptote is. So our equation for this one is going to be y equals 2 over x minus 5. And then finally, for this last one, we have a being negative, and then over 1, down 1, 2, 3, so it's going to be negative 3. H is again at 0, and k this time is at 4. So we're going to have the equation y equals negative 3 over x plus 4. All right, so that's all there is to this section. A little bit about transformations, a little bit about graphing. In the next video, we're going to be talking a little bit about how you work with rational expressions, how you perform certain operations on them.